Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on sampling distribution part 7. Let us recall the previous session. In the previous session, we have discussed about sampling distribution of means, in that in a particular case sigma unknown. Sampling distribution of means when sigma is unknown. In that we introduce t distribution and we have solved some problems on t distribution, that means finding the area or probability using the t table. So if t value is given, we can find alpha. Similarly, if alpha is given, we can find t also, and the t variable is x bar minus mu by s by root n. So we introduce this t distribution when the sample size n is small, that means n less than 30. If a small sample is given, we use t distribution, or else if the standard deviation of population sigma is unknown, then we use t distribution. Coming to today's presentation, today I am going to introduce two distributions, chi-square and f. These two comes under sampling distribution of variances. In the sampling distribution of variances, we use chi-square distribution. What is sampling distribution of variances? Let us draw samples, for example, k samples from a given population. Samples, first sample, second sample, third and so on, kth sample, and calculate the variance for each of these k samples. So S1 square, S2 square, S3 square and so on, Sk square, and the set of these two values is called sampling distribution of variances, or we denote it in the form of a table. This is called the sampling distribution of variances. Here we use the chi-square distribution, and this is the symbol for chi-square, and also we introduce f distribution in the case of ratio of variances. Now, sampling distribution of variances. The theoretical sampling distribution of sample variance for random samples from normal population is related to chi-square distribution. For example, let us consider a population with variance sigma square and draw a random sample from that having the variance s square. So sigma square is the variance of the population, whereas s square is the variance of the sample. Then the chi-square value is given by chi-square equal to n minus 1 multiplied by s square by sigma square. So we consider the sample variance in the numerator and population variance in the denominator. And using the formula for sample variance, this is sigma xi minus x bar whole square by n minus 1. These two, n minus 1 and this one gets cancelled, and we can rewrite this chi-square value as sigma xi minus x bar whole square by sigma square. Is a random variable that follows chi-square distribution with nu equal to n minus 1 degrees of freedom. And also the chi-square distribution curve is shown in this figure. This chi-square curve is not similar to t curve or standard normal curve. The chi-square curve completely lies in the positive quadrant. So here this is chi-square value and this is f of chi-square, and the curve lies completely in the positive quadrant. Now coming to the properties of chi-square distribution, just now I told the chi-square curve lies completely in the positive quadrant as the chi-square value varies from 0 to infinity. That means chi-square value takes only the positive values. That's why the curve completely lies in the first quadrant, that we can see here in the figure. And chi-square curve is not symmetric, as it is completely in the positive quadrant. It is not symmetric. It depends on nu, the degrees of freedom. Chi-square value depends on degrees of freedom nu. It is unimodal and additive. Unimodal means the mean, median and mode coincides for a chi-square distribution. And additive, chi-square is additive. That means, for example, let us consider chi-square 1 that follows chi-square distribution with nu 1 equal to n1 minus 1 degrees of freedom, and chi-square 2 that follows chi-square distribution with nu 2 equal to n2 minus 1 degrees of freedom. Now, let us consider chi-square 1 plus chi-square 2 that follows chi-square distribution with nu 1 plus nu 2 degrees of freedom. So, this property is called additive property. So, chi-square satisfies additive property. Next, in chi-square alpha, we denote the values using this notation chi-square alpha. Here chi-square is the value of chi-square and alpha is the area. In chi-square alpha, this alpha denotes the right side area to that chi-square value. For example, here you can see this is chi-square alpha. So, this region is alpha. So, in chi-square alpha, alpha denotes the right side area to that chi-square value. For various values of chi-square, the table was constructed which is called chi-square table. And also, in chi-square table, the leftmost column denotes degrees of freedom. Leftmost column, that means the degrees of freedom. The leftmost column denotes the degrees of freedom. The top row are the areas or probability alpha. This is degrees of freedom nu, and the entries are chi-square values. The entries are chi-square values. So, that we can see here in the table, the leftmost column degrees of freedom nu, and the top row area or probability alpha, and the entries are chi-square values. So, these are the chi-square values. Next, F distribution. This F distribution is also known as ratio of variances distribution. Ratio of variances. Let us consider two populations, population 1, population 2, having the variance sigma 1 square and sigma 2 square respectively. So, sigma 1 square is the variance of first population, sigma 2 square is the variance of second population. Let us draw a sample of size n1 from population 1 having the variance s1 square, and draw another sample of size n2 from population 2 having the variance s2 square. Now, let us consider the f value as the ratio of these variances. Now, to test whether the two samples have come from the same population, we consider s1 square by sigma 1 square by s2 square by sigma 2 square. So, that is given here. In order to determine whether the two samples have come from two populations having equal variances, we consider the value of f as s1 square by sigma 1 square whole divided by s2 square by sigma 2 square. By simplifying that, we get this one. Under the assumption that sigma 1 square equal to sigma 2 square, that means the population variances are same, then these two values will be cancelled, and hence the final formula to find f value is s1 square by s2 square. So, this is the final formula. It follows F distribution with nu1 comma nu2 degrees of freedom. Here we have two different samples of sizes n1 and n2. So, nu1 is n1 minus 1 and nu2 is n2 minus 1. So, F follows F distribution with nu1 comma nu2 degrees of freedom, and also it is customary to consider the larger value of the two variances in the numerator. So, we have to consider the largest sample variance in the numerator, and F distribution curve is similar to the chi-square curve, and it completely lies in the positive quadrant. So, that we can see in this figure. And properties of F distribution. F distribution is also known as variance ratio distribution. F curve lies completely in the positive quadrant, and F determines whether the ratio of two sample variances is too small or too large. So, this is an important point. This F value determines whether the ratio of two sample variances is too small or too large. For example, if F is closer to 1, that means what is the formula? F is s1 square by s2 square, which is almost equal to 1. that implies S1 square equal to S2 square. So, if F is close to 1, then the two sample variances are nearly the same value, having the same value. So, if F is close to 1, the two sample variances S1 square and S2 square are nearly same. And also here, we denote the F value as F alpha nu 1 comma nu 2. Here F is the value of F, alpha the area, nu 1 nu 2 are degrees of freedom, and F value depends not only on nu 1 nu 2 but also in the order in which they have stated. That means, for example, 2 comma 3 is given, then F alpha 2 comma 3 and F alpha 3 comma 2, these two values are not the same. So, F depends on the order also, not only on nu 1 and nu 2 but also in the order in which they have stated. And there is another important property, F1 minus alpha nu 1 nu 2 is equal to 1 by F alpha nu 2 nu 1. 1 minus alpha nu 1 nu 2 becomes 1 divided by F alpha, this nu 1 nu 2 will be reversed, nu 2 comma nu 1. And F table is constructed only for two values 0.01 and 0.05. So, therefore, we have two different tables for F. One is for alpha equal to 0.01 and the other one is alpha equal to 0.05. Now, for example, if I need to calculate for 0.99 F 0.99, so alpha is 0.99, but the table was constructed only for 0.01 and 0.05. Then I convert this value using this property. For example, this is nu 1 comma nu 2 and this becomes, I can write this 0.99 as 1 minus 0.01 nu 1 comma nu 2, and using this property 1 divided by F 0.01, these two values will be reversed, nu 2 comma nu 1. Similarly, we can find F 0.95 also. So, 99% values comes under these four areas. And just now I told you F table was constructed only for two values of alpha. For 0.01 the table is given here and 0.05 the second one. And in F table the leftmost, the top row denotes the degrees of freedom nu 1, leftmost column degrees of freedom nu 2, and the entries are F values. And where is the alpha? Particularly it was constructed for 0.05 and 0.01. So, this table is for 0.05, alpha is fixed 0.05. Top row degrees of freedom nu 1, leftmost column degrees of freedom nu 2, and the entries are F values. Similarly, for 0.01 again the same, nu 1 top row, nu 2 leftmost column, and the entries are F values. Let us solve a simple problem on F distribution. So, here for an F distribution, find F 0.05 with nu 1 equal to 7 and nu 2 equal to 15. So, F first problem 0.05 for nu 1 is 7 and nu 2 is 15. So, degrees of freedom, we have to follow the same order 7 comma 15. Just now I told you F depends not only on nu 1 nu 2 but also in the order in which they have stated. So, nu 1 is 7, nu 2 is 15. We need to check the value, find the value of F in 0.05 table 7 comma 15. So, nu 1 7, 15 here. So, the corresponding value of these two is 2.71. So, this is 2.71. Similarly, the second one F 0.01 for 24 comma 19. 24 comma 19 in 0.01. 24 here, 19. So, corresponding value is this 2.93. Now, the third one F 0.95, just now we have discussed. The table was constructed for 0.01 and 0.05. Now, to find this value, we use 0.05 table also. Here, this is for 19 comma 24. and this f 0.95 can be written as 1 minus 0.05 19 comma 24. So which is equal to, using the property f 1 minus alpha nu 1 nu 2 is equal to 1 by f alpha nu 2 nu 1. Using this property, this is 1 by f 0.05 and reverse the values of this nu 1 and nu 2. So 24 comma 19. In 0.05 table, find the value of f for 24 comma 19 degrees of freedom. 24 and 19. So the corresponding value is 2.11. So 1 by 2.11. That gives the required value of f. Similarly, the fourth one, f 0.99 for 28 comma 12. Again, we use the same property. I can write this 0.99 as 1 minus 0.01 for 28 comma 12. When I use this property, I have to interchange the values of, when I use the property, I have to interchange the values of nu 1 and nu 2. So 12 comma 28. In 0.01 table, for 12 comma 28, 12 comma 28. So the corresponding value is 2.9. So 1 by 2.9. That gives the required value of f. So like this, using the f distribution table, we can find the value of f if alpha is given, or else if alpha is given in the reverse manner, we can find the value of f also. So if f value is given, we can find area. If alpha is given, we can find the value of f also. Let us solve one more problem. Determine the probability that the variance of the first sample of size 9, so n1 equal to 9, will be 4 times as large as the variance of the second sample of size 16, n2 equal to 16. So that implies nu 1 is n1 minus 1, 9 minus 1, 8 degrees of freedom, and nu 2 equal to n2 minus 1, 16 minus 1, 15 degrees of freedom. And what is the given condition? The first sample variance will be 4 times as large as the second. So given that S1 square is equal to 4 times S2 square. And what is the formula to find f? S1 square by S2 square, and it is customary or mandatory to consider the largest value in the numerator. Here S1 square is 4 times that of S2 square, that means S1 square is the largest value, and I can replace this S1 square by 4S2 square by S2 square. So these two gets cancelled and the value of f is 4. So f alpha for 8 comma 15 degrees of freedom, the value is 4. Then what is the value of alpha? So here in this problem we need to find the area, because we have the value of f and degrees of freedom already given, nu1 equal to 8, nu2 equal to 15. So we need to check in which table, either in 0.01 or 0.05. F value is 4 corresponding to 8 comma 15 degrees of freedom. So for 8 comma 15 degrees of freedom, the value of f is 4. Let us check. 8 comma 15. So this is 8. This is 8 and 15. The value is 2.64. It is not 4. So alpha is not 0.05. Let us go back to 0.01 table. 8 and 15. Yeah, here the value of f is 4. Therefore, the area alpha is 0.01. So from f table, alpha equal to 0.01. So like this, we can find the value of f if alpha value is given, or else the value of alpha if f is given, using the f distribution table. So this is for today's session, and we will meet in the next session. Thank you.